Hello, welcome to my channel and welcome to chapter 7 of the cross origin resource sharing course. And in this chapter, we're going to talk about course request types. In the previous chapter, we talked about the course syntax and we looked at all the headers that are involved on both the client side and on the server side while executing the course specification. So, what are the course request types? I remember I've mentioned previously that CORS is an extension of the HTTP protocol that is used by HTTP servers to relax the same origin policy in a controlled manner. And the purpose of doing this is to protect user data from unwarranted access or manipulation. So, how does CORS do this while at the same time making sure the user data is secure? How do servers relax the same origin policy without compromising user data? And how it does that is partly by identifying different types of requests and categorizing them separately. Each request type faces a certain level of scrutiny and control, all right, because different request types have different levels of risk. And while mitigating these risks, we don't want to be overly stringent or overly strict over a request that may not really have any real damage to user data. And this strictness would, remember, this policy actually adds an overhead. You take a performance hit. Client applications take a performance hit typically while respecting the course specifications. So we want to reduce the performance hit as much as possible. It's a give and take situation. It's a trade off. You trade off some bit of security for usability. And while doing this, you just need to understand exactly the level of risk a certain request is going to pose to user data and apply appropriate and proportionate mitigative measures to it. You don't want to block requests just like the same origin policy does simply because it's cross origin, because there are so many legitimate users for cross origin requests. So, likewise, even within the course specification, we categorize requests into different types. Each one reflects the level of risk it poses to user data. So let's look at the types of requests. Another, I should have added a table of contents here. We have simple requests. We have credentialed request or non-simple. And then we have, not credentialed, but preflighted. Preflighted is the opposite of simple. And then we have credentialed. So okay, let me just finish that up. So let's scroll down here. I have another diagram here that talks about the first two request types. Simple requests on the left-hand side and pre-flighted requests on the right-hand side. For those that have not heard of these terms before, I have two diagrams for each side. And basically, because the distinction between what is a simple request and what is a pre-flighted request, or alternatively called non-simple request, is that, as I mentioned earlier, the level of risk a request poses to user data. And the browser behaves differently when it encounters a simple request as it does when it encounters a non-simple request. And that behavior is captured in these diagrams at the top of the boxes. Okay, so a simple request from the perspective of the browser does not need, it poses so little risk that it does not need any extra checks. When the browser encounters a request from a script and analyzes it and concludes that it's a simple request, the browser simply forwards the request to the server as the script sent it. If the request indeed poses some risk, those risks are mitigated by default behavior of the browser, especially if the server does not have any proper course set up. Then the browser knows what to do. to in such a scenario. However, for a non-simple request, the browser may not have all the information it needs to handle this request, and it absolutely needs the server's consent in some areas. So, what happens in that case is the browser will send an advanced request ahead before sending. It first poses the script's request and then sends its own request, its own formulated request. This request is not created by the developer. It is created by the browser and sent to the server. And it uses the HTTP method options. It doesn't use any of the put, get, post, and all. It uses an HTTP method called options. And when it sends this request to the server, it includes the origin and the other request headers we just looked at in the previous chapter. And when the server receives this request, it responds with the response headers that the browser can then read and decide whether this request can be sent or it shouldn't be sent. And if it is sent, what what other additional mechanisms should the browser put in place to prevent to mitigate any risk? Remember, we said this is a very controlled way of relaxing the same origin policy. And these are the controls. It happens gradually, step by step. It's not an all or nothing kind of policy. So these are the controls we're talking about. The pre-flight request is sent by the browser. The server sends back the CORS headers we just looked at. The browser reads them and then makes a judgment on what to do with the request. So we've just talked about the execution model of the browser, and now let's look at what makes a request simple versus what makes a request non-simple from the perspective of the browser. So you create a fetch request or Axios request or an Ajax request on your in your script in your front end code. The browser, this request is submitted to the browser for sending to a server whose URL you've put there. The server reads the request, looks at the origin, looks at it. It concludes that this is a cross-origin request. Then it analyzes some specific parameters in the request, and based on those parameters, it concludes whether it is simple or non-simple, in which case it will be pre-flighted. So before we go and look at the parameters the browser checks, it's just important to understand that when a request is not simple, the moment the browser concludes that it's not simple, then automatically that makes it non-simple. And any non-simple request will be pre-flighted, as we've just discussed what a pre-flight is. And this is important because when we just understand what a simple request is, then by extension, we will have understood what a pre-flighted request is. So let's go through the parameters one by one. The first parameter is this. Remember, by this time, the browser has concluded that this is a cross-origin request, so we don't really talk about the origin. So the first parameter is the HTTP method used. If your request is a put, post, delete, or any other HTTP method, it has a different bearing on whether it's a simple request or not, and whether it's pre-flighted or not. So there are some HTTP methods which are considered safe. Get is one of them, head is one of them, and the last one is post. By default, the CORS policy considers these HTTP methods safe. And as I did before, the post method is suffixed with an asterisk here or a star, because remember I said that it's a little more complicated when it comes to a post request. But however, suffice to say right now that for the HTTP methods that are considered safe and don't need pre-flighting are get, head, and post. Then we are going to talk a little bit more about the complication around post. The second parameter considered by the browser is the is whether you're using safe request headers. And also, as we talked before, a request header is basically a way to extend the HTTP protocol. The same thing the course policy does, course specification does. As developers, we can extend that HTTP protocol by adding our own custom headers. And these headers could communicate anything. When they are request headers, it could mean that maybe the application, maybe the single page application that's sending the request, would like to identify itself. Maybe you have front end apps, perhaps in a monorepo. Each one does different things. They're modular in nature. One front end app deals with user management, the other one deals with product management, the other one deals with perhaps other infrastructural issues. Maybe another one deals with accounting. So each app may have different needs and different levels of exposure. Maybe some are used internally in the company, okay, and some are used publicly by your users. So you might want to share, you might name these front-end applications differently, and each application is supposed to append a header, a custom header, and put its name there. Okay, you might use it on the back end for different purposes, but the idea is you can extend the protocol by adding your own custom headers as long as the server understands it and the client understands it. So such kind of scenarios requiring custom headers are also strictly controlled by the same origin policy, by the cross origin resource sharing specification. And remember, on the back end, for example, you might say any app whose X app name, assuming that the header name is X app name or app name. Perhaps on the back end, you apply different levels of authentication for different apps, and you validate the users of the app based on the app name. All these very important and consequential ways of processing data can be taken advantage of by a client. For example, I've worked on an app where if the request is coming from a mobile app, it the mobile app identifies itself. Very simple. We just have the header name is the header value is mobile. Others, the header value could be admin app. So when it's a mobile app, there is a different level of authentication applied. So a hacker could take advantage of this and manipulate data on the server. So what happens is cross-origin resource sharing recognizes this particular risk and says we by default we don't accept custom headers. So what are considered safe headers are headers that are known to the HTTP protocol. The meanings are known, but any header whose meaning is not known, as those which are defined in a custom manner by developers or a company, are strictly controlled by this cross-origin resource sharing policy, and they are not considered safe. And then the next one is the safe content type. If you use safe request headers, this request is considered simple. If you use safe content types, that request is also considered simple. And what are safe content types? Safe content types are content types that that okay. It's not really. I cannot say they are known by the server because also and some unsafe content types are also known by the protocol. However, safe content types are specific, they are listed. We are going to look at them in the next slide or diagram. And what I can say is that when I put a star on the post HTTP method, and I said there's a caveat. The caveat, I had also mentioned this earlier, but it's not bad to repeat. The caveat is around the content type. If you have a post request, it's safe to 50%. Then the browser goes ahead to check the content type. Because remember, post sends data to the server to create a new record or to create a new file or something like this, to create a new resource. So what the browser does is to look at the content type. It only allows a specific set of content types to be considered safe. Anything outside that is not considered safe. All right. And we're going to look at the list of safe content types, and you'll be able to fully understand the caveats around post request. Yes. Then the second last parameter is the event listeners, specifically on file uploads. So remember, this is another caveat on post request. Sorry, I said it's only one caveat of content type, but when you're doing a file upload on on a front end application, Typically, it's a post request with content type multipart format, and that content type is also one of the safe ones. However, remember two things. We're trying to control access to user data, try and protect user data, okay? And at the same time, um, event listeners actually listen to events from the server when you're doing file uploads. Think about how you implement progress bars when doing file uploads on front-end applications. So you see the progress bar moving from 0 to 100 based on how many bytes of the file have been uploaded. So how does the browser know how much of the file has been uploaded? It gets a feedback from the server on how many bytes have been received. Then it computes the percentage and shows it in the progress bar. So the fact that there is server data coming back to the client when you register an event listener means that effectively the script is already accessing data from the server. And we don't want to expose any data whatsoever from the server to the script if we don't have to. So the moment you register an event listener on a file upload script, then automatically this is not considered a simple request anymore, and it will be pre-flighted. Even if it passed the first two parameters, it's a post request. Now the safety of post request is down to 40% or 39%, 33%, let's say. The content type, if the content type checks out, multipart, that's at let's say 66%. And then lastly, if there is no event listener on the file upload, in case the post is used for file upload, then it takes the safety of that operation to 100%. So the browser checks all this and decides accordingly. Then the last parameter is the usage of readable stream. So if what typically when you're communicating between server and client, the browser sets up an HTTP connection to that server first. After setting up that connection, then it sends the message from the client to the server. And then the server sends back the response through the same connection. And remember the HTTP header called um, connection, and there are values like keep alive, basically meaning keep that connection alive for future requests. However, there's another mode of communication where the browser establishes a connection with the server and streams data between the client and the server. In the first instance, the data is collected, is the bytes are sent from the client, and when they reach the server, they are decompressed and collected together before exposing it to the server application. However, in a streamed connection, this client sends these bytes, and these bytes reach the server as and when they reach. The server receives them as and when they reach, and it can process them individually. The bytes are processed individually. However, uh, this is a risk because then the server can also send responses to the client in a chunked format. Basically, it streams bytes to the client side. And this, similar to the file upload scenario with event listeners, this is the server sharing information with the client. And remember, we are protecting any sharing of information between server and client without proper controls. So if the browser encounters a readable stream in your operation, automatically it flags it as a non-simple request, and that request must be pre-flighted. So those are the five parameters used to decide if a request is simple or not. And then crossing over to the side of pre-flighted request here, basically it's just the opposite, or the other side of the coin. Unsafe HTTP methods like put, delete are considered unsafe and they must be pre-flighted. Unsafe request headers, those are custom headers that are not understood. Unsafe content types, I said we're going to look at them. There's an event listener or a usage of a readable stream. And of course, here I could also add post with a star. Then you can understand that the post will be analyzed alongside the content type, alongside the event listener, and alongside the usage of a readable stream. So this is it. I hope the difference between simple request and non-simple or pre-flighted request is safe. And now, as I promised, let's look at the difference between the difference between safe and unsafe headers. So I have two boxes here. One is referencing the access control expose headers. This is one of the response headers we looked at in the previous video. And then access control allow headers. This is the one sent by the browser to find out if the script can send some specific headers. So I'll not go through each of these headers one by one, but these are standard HTTP protocol headers. And remember, I mentioned that safety or non-safety of a header depends on whether it's a custom header or not. And I talked about the example of custom headers. So these are standard response headers and they are exposed by default. They don't need to be listed in the access control expose headers course header. But if you add a custom header that the server is going to set on the response to send to client, then you need to add it in the expose headers for it to be visible to the script when the response reaches the client. And then on the side of the client, these are pretty standard HTTP headers, and really there's a caveat on content type. I just explained it, the content type. So this is when I talk about the content type in a little more detail from the client perspective. Safe content types versus non-safe. The range header is quite a rare header, so I will not really talk about it. It's not going to change much. So the safe content types you can set on the client side that will make a request be treated as safe and a post method be treated as safe are these ones: form URL encoded, text plain, and multipath. This is the one we use for the file upload. And this is the one used for form uploading. Then text plain is basically a content type that is just text. It's not JSON, it's not XML. So this means that for those used to REST applications, anytime you're posting data, of course you're going to use JSON, and maybe you're going to use XML. These are not considered safe content types. Now, the reason why JSON and XML are not safe, because before the course specification was designed, we had already form uploads. The way web applications used to collect data is using forms. Before even single page applications came up, there were, it was mostly MVC applications exposing forms that are coming from the same server, that are sent by the same server. The user fills it in and submits the form. So these ones are basically the standard form submission with this content type is considered safe because there's another mechanism for making sure this is a safe operation. And you can't post a form that doesn't have, that is not signed by the server. It will be rejected. If you've heard about another protection mechanism called cross-site request forgery token, CSRF tokens are used to ensure the safety of data posted in forms. So from the CORS perspective, CSRF already protects post requests with form data, and file uploads are also safe because of this. So when the cross-origin resource sharing spec came about, it couldn't affect already working web applications. That's why it was decided that, okay, let post requests with form data be considered safe along others. And remember, because of single page applications, REST APIs are very popular. They communicate over JSON. They communicate data in JSON format. So those are the ones targeted by restrictions of cross-origin resource sharing. So I hope that is clear now. We've looked at the safe and unsafe headers. Then the last request type from the perspective of course is what we call credentialed requests. I'd mentioned this sometime like two videos back. A credentialed request has some parameters to define it. And here they are. And I just left these other diagrams for the whether it's preflighted or not here. But credentials are secret information or information that should be protected because maybe they give elevated privileges to a client, like the session cookies and authorization header. So A request can be credentialed or non-credentialed. When a request is non-credentialed, it has these three qualities or characteristics. There are no credentials in the request header. There is no authorization header. There is no cookies. And then we have it has no credentials in the response header. And thirdly, the client has not requested to include the credentials. So what happens is by default, the browsers will strip off any credentials from a request by default. And you'll not see any failures, but you'll just see your authorization header is not going through in the request. And this is the cause of a lot of debugging pain because there is no, error message. But if you understand CORS, then you'll be able to know where to check. So the browser protects user data by removing credentials so that privileges are not sent, are not given to cross-origin clients. And so when this happens, the first step a developer might do is to configure the script to include credentials. Now, when this happens, the browser will send a pre-flight request to check the access control allow credentials. You remember that? You remember access control allow credentials header? If the server responds with true, then the credentials will be sent. If it responds with false, the credentials will not be sent. So this is just a high level overview of the different types of requests. And in a future video, I'll go into some of them into details and with some demos. So thank you very much for following along and see you in the next video. Thank you.